All right. Thanks very much for coming out to this. Hope your last day's going well. I know it's a lot, and you were out late last night, at least if you were hanging with me. I went and hid back in the recording room after doing the Goliath story to get a couple of things done, and it turned out I stayed a bit too long. We were the last people out of the building. My name is Richard Campbell. I make a lot of podcasts, which is a great source for me of learning. I get to talk to all these awesome people about different technologies. It's easy to get an AI show today. In fact, arguably I have too many of them. But my experience dealing with machine learning technology, so forth, go back to before the fun times. In fact, in 2016, I was doing a project for the Vatican, for the former Pope, Pope Francis, where he had this Laudato Si, this idea that capitalism and social conscience aren't mutually exclusive. And so we were actually part of an accelerated group helping social conscience companies be successful, helping them to grow. These were things like bringing solar lights to developing parts of the world, that kind of thing. It was a very cool project. But in the middle of it, I was asked by a group at the Vatican if I could talk about the state of artificial intelligence at the time. This is in 2016 when we just called it machine learning, right? The AI moniker wasn't very hot. And so I put together a talk I called The Perils and Promises of Artificial Intelligence. And just, mostly at the time we were focused on things like, you feed this thing bad data, you get bad results. The classic one was we're using machine learning to determine likelihood of crime, and so the biases that affect police officers and who they select to look for criminal activity are naturally reflected in the data, which reinforces that cycle. That was the kind of conversation we were having. Then, obviously, things have gotten weirder from there. But I backed, one of the things I wanted to ground myself in talking about that was to really talk about the origin story, too. Because the word artificial intelligence is really old. In 1955, Marvin Minsky and McCarthy and a few other really bright folks thought that the computers of the time, and this is the 50s, so this is before the transistor, much less before the IC, with electromechanical computers, that they could do intelligence-like things. Now, these are scientists and experienced scientists, so they're used to raising money, which just reminds me that artificial intelligence is a marketing term. It's designed to raise money. And it was successful. They were pitching the US military that they should do logistical engines using a form of machine learning very early, obviously, with electromechanical computers. And it worked. They got the funding for it. And I don't know if you've noticed, but the Americans are very good at projecting force around the world. And it's based on some of the software that helps organize how they move resources around to make it possible. Into the 60s, there were other folks that were experimenting with this kind of software. And one of them was a guy named Joseph Weizenbaum, who wrote a bit of software to demonstrate how strange human language interaction was like. And the program was called ELIZA, and he based it on Rogerian therapy theory, where it's kind of just repeating words back to you. And I don't know that he meant it as a joke so much as a demonstration of how little information you need to train together reasonable sentences back in software. What was shocking is just how much time people put into ELIZA. And this is in the middle 60s, so it's way back there. And he was really pressing on these elements of human psychology that are sort of remnants of our pre-technological areas. So we tend to anthropomorphize. One of the strategies of surviving on the veldt was if you can project intelligence onto your prey animal, you can predict where they're going to go. Another aspect of that is a thing called pareidolia, or our tendency to see faces. And you can think of that again, if you're a hunter-gatherer on the veldt, the first one to recognize that there's a predator by seeing that predator's face and get running is probably the one that's going to survive. The ones that are slower, they're the ones who are going to be the meal. And even if you're wrong, the side effect of being wrong is small. You just get laughed at, but you live when you're right. And so that behavior is persisted, right? We see faces in all kinds of things. Even the things we make maybe unintentionally have faces. Sometimes we see faces on other planets. This is the famous face on Mars picture. Turns out just a hill with some shadows, not a big deal. And we do deliberately put faces into our products now because we like them. They'll give names to cars. It's weird. But that's human nature, and it's been exploited lately more than usual. Now, artificial intelligence only gets sort of known to regular humans in a movie, in 2001: A Space Odyssey, 1968, Stanley Kubrick's masterwork. Extraordinary film if you haven't seen it. And there's a computer named Hal, and Hal spends most of the movie trying to kill everybody. Kind of setting us up that now we have this trope that's great for storytelling of intelligent computers trying to kill everybody. And you can fast forward to the 80s and you get Terminator, and you can get into the 2010s and you get Ultron. Like over and over and over again, we get this same trope around artificial intelligence. So when you get new products, the fact that you would use this name is a bit disturbing because it's deeply misconstrued. Like, people think they know what it means because they've seen a movie, and it's not at all what we're actually making. Now, I've skipped a bunch of history, anchoring in the 50s and quickly moving through, because there's several periods of time where different technologies grabbed the name artificial intelligence. But this current period, I would call the generative AI period, largely starts with three different people. Let's focus on Hinton. Because Hinton's story is also part of the problem that we're in right now. And Hinton was English, although he got his degree in AI in the 70s, but he was working out of the University of Toronto for many years, and he was big on early neural net technology through most of the 80s. Now, at that time, neural net technology was quite shallow, sort of input layer, hidden layer, output layer models. And a few things worked in that. In the 80s, they largely worked out models to do some handwriting recognition, identifying postcodes, identifying checks. Like, they actually got to product level even then. But as it got more complicated than that, he realized that there was an advantage to going to a deeper model. Now, we call them neurons, but they're not. They're logical constructs or memory locations, really, but it was the connections between them and how we do the weighting. And Hinton wrote a very famous paper on backpropagation, where he essentially defined an idea for how to do a 10-layer deeper, very deep neural net model, and how to adjust the weights on those models to get successful behavior, but basically ended it with the computers of the time really can't do this. We don't have enough clout. And the paper largely sat on the shelf for several decades. In the 2010s, so in the Ultron era, there was a competition going on called the ImageNet Large-Scale Visual Recognition Challenge. So it was this idea of, can we get software to recognize the content of images? And in 2010, that was essentially impossible. Fast forward 15 years, we just take for granted now that our phone is perfectly capable of recognizing the content of any photo. And that comes from this competition. And for the first few years of the competition, the accuracy rate, this was 14 million labeled images, mostly gleaned from social media, so thanks. And the accuracy rate in these competitions, if you got 40%, like, you were rocking it, which isn't actually useful, but which is sort of the reality of the way it was. And it was a group of students from Hinton's team, including Ilya Sutskever, that dusted off that old paper and built a deep neural net to do image recognition. And their first run through, they got 80% correct, and by the next year it was 100%. And image recognition was suddenly a solved problem, to the point now where we forget that 15 years ago it was an impossibility. Today, it's just, we expect that to work. Now, that's not the only place that this kind of technology is being experimented with. These deep neural nets were also being trained on language even in the early days. There was a group out of the Stanford Research Institute that was experimenting with voice recognition. And we'd had voice recognition for years, but back then you had to do a lot of your own training. If you bought a Dragon naturally speaking board and set up a microphone and things, you would have to repeat phrases to it over and over again until it got some ability to use your voice. And it was getting 92% accuracy. Was about as good as you're going to get from that, which means every paragraph had an error or two. But with SRI, they were doing a lot of pre-training and actually being able to build out the model so that they were really good with languages right out of the gate. And Apple acquired that company and added an extra I to it. Now you know it as Siri, which is now more or less a dead product. They're revamping it into these new models. But that was another entire separate lineage of generative AI happening at the same time. And then we just took for granted when that started happening that it recognized your voice. Unless you were Australian, I guess the training set didn't have a lot of Australian accents, so it was limited that way. So by 2013, lots is going on there. That's a picture of Hinton and Siskovar in the background there, and another fellow. And they were approached by Google saying, hey, you should set up a company to start to commercialize some of the technology you've made around image recognition. And so they did that in 2013 and were immediately acquired by Google. And so they all shipped off down to Menlo Park and joined this group at Google called Google Brain. It had been formed in 2011. And so they were part of this brain trust of exploring artificial intelligence technologies. And this is where we get those stories you remember back in 2014 or so. There was a lot of well-known technology folks saying, hey, artificial intelligence is coming, and it really needs to be done out in the open. We have a lot of concerns. And this was guys like Bill Gates and Elon Musk and even Stephen Hawking all made these little video clips about their concerns about artificial intelligence. And the response to that ultimately was that a group of tech billionaires, including Peter Thiel and Elon and Sam Altman and a few others, formed a company called OpenAI. And their whole goal was to yank those scientists out of Google, to persuade them to work in a better company infrastructure, to build up this technology for the betterment of humanity, except for that part where they lied. And they, of course, it was a bunch of billionaires, so you expect them to contribute a lot of money, but they didn't do that either. So the entity sort of limped along. Like for a long time, Elon kept saying, oh, I put $100 million into OpenAI. It just turned out not to be true. It was like $16 million and 8 Teslas. Okay. And then he tried to take control of the company entirely and got booted out, which is why he's still angry with Sam Altman, and you see this constant jockeying. It's all from these early days of OpenAI. And they had very limited funding. Like they didn't have a lot of resources for the things they wanted to do, but they were making progress. And even by 2016, with image recognition evolving, not necessarily out of OpenAI, our friend Hinton, this is a clip from a video, from a recording he did where he said, listen, like radiology is now a solved problem. We have image recognition. It'll find cancer better than the human would. Like he literally said, if you're a radiologist, you're like a dead man walking. He was just wrong, like wildly wrong. Now, to be clear, radiology has been significantly impacted by image recognition technology. There's over 700 different kinds of recognition models authorized by the FDA for doing medical image recognition. But the reality is as they sped up the ability for radiologists to do recognition, to identify images more quickly, the demand for imaging has gone up dramatically. And you can't train radiologists that fast. So the demand is more than tripled, but the number of radiologists has gone up about 10%. It takes a decade to make more radiologists. It's just not that easy. And to me, it's one of those early cues. You know, the future is here, it's just not evenly distributed. Well, here we have a high-skilled, highly valued industry that has had these technologies in from the very beginning, and the real impact on it is to make it grow, with some caveats. There's lots of pressure on it. You know, there's this whole dynamic of, is the doctor still in charge of checking the image, or is the doctor just responsible when the technology gets the image wrong? Right? There's a challenge there in the legal and ethical approaches to using this technology, but the radiologists have sort of led the pack here. So meantime, back at OpenAI, they were working on a universal translator. That was their idea. They came up with a strategy to tokenize human language into a token set that could then be outputted in virtually any other language. And as they were building out that model, they found that taking sentences from the internet, they could take the first half of the sentence and have the second half of the sentence basically generated effectively. And you could mix that up and get different versions of it. And they called this a generative preformed transformer. And the first version largely didn't get seen, but by the GPT-2, and this is around now we're in 2019, is the first real visual sign we got of what they were building. And fairly quickly they realized they didn't want to actually release this as open source. Not so much from a greed factor, from the concern what people would do with it. They made multiple sizes of GPT-2 because they were so broke they couldn't even afford to run their own largest version. Right? $1.5 billion per RAM was just a lot of compute, and so they made lighter weight versions so they could do their own testing. And the cloud was too expensive for a lot of stuff and not particularly good at it, so it was a challenge to make this operate. And this is around the time that Microsoft shows up. So Kevin Scott, who is the former CTO of LinkedIn, now working in the office of the CTO at Microsoft, has a mission. And his mission was to find workloads for Microsoft Azure. That was his job. And because he came from the Valley, he knew a lot of the OpenAI folks, and he saw what they were doing, and he now kind of famously wrote this letter to Satya, where he said, look, we've been experimenting with AI inside of Microsoft. We're not getting too far with this language stuff. These guys seem to be onto something, and they're really broke. I think we should invest $1 billion in them and then make them spend it on Azure. Which is a pretty good deal for Microsoft if you think about it. I take $1 billion and I make an investment, so now I have an investment of $1 million, and then they spend it all on me, so now I have $2 billion. Anyway, they went for it, obviously, and that gave them enough funding to start building some larger models and to start doing bigger experiments while also moving the workloads to Azure, so they had a lot more compute available to them as well. And in 2020, the OpenAI folks published a fairly famous paper called the Neural Scaling Laws. And this paper, if you read it objectively today, says exactly the opposite of what every machine learning expert ever says, which is that when you are training a model, don't overfit it. If you train it on the data too much, till you get up to a high level of fit, it will only be good on the training data, it won't be good on real data. Where this paper said, if we keep feeding a larger and larger, all the text on the planet into this system, bigger and bigger, it'll just, at some point, it'll just hockey stick up and be wildly better. And one would argue this paper is the anchor for much of what has happened since, because all of the tech giants kind of jumped on this. It serves the tech giants to have large amounts of compute being demanded to build out these larger and larger models. And so by 2020, the spring of 2020, OpenAI produces GPT-3. This was celebrated by Microsoft because it was all run on Azure. They called it the 5th largest supercomputer in the world when they made it. Although it was 2020, we were busy. I don't know about you, but I was a little distracted in May of 2020. And it was 175 billion parameters, so it was much larger than the largest of the GPT-2s. And it wasn't that good. Like, especially the first versions of GPT-3 were just not that impressive. They were big, but their responses were not awesome. But the GitHub guys, again, down in the Silicon Valley, they thought, hey, what if we got away from English languages and focused on programming languages? And so they came up with Copilot well ahead of just about everybody else. And you can tell that it was a GitHub because it's a really good name, right? Like Microsoft wouldn't have come up with a name that good, right? And the implication's perfect, really, if you think about it. It's like, it's the Copilot. You're the pilot. It's still your fault. And these were early versions, so they were still working through some issues, but they had enough success with this that Microsoft kicked in another $2 billion so to spend on Azure, because they used up all the Azure for the first one. But initially, OpenAI did not immediately start building a better model. What they were recognizing is they needed a second-order training set, that the initial training set they were doing purely off the internet really came back with a large array of marginal results. And so the second order training set was, give me your 5 best responses to this phrase, and then they'd have a human rank those phrases. And so they spent a lot of that money having people build this second order training set by ranking responses over and over and over again. Especially through 21 and 22, that's what they were doing. And that second order set became quite large. And they're mostly done in places like English-speaking places, but inexpensive, Indonesia, Philippines, that sort of thing. And by the fall of 22, they were out of money again. And so they had this idea. Let's let the public try this. Let's just put it out there and let the public do the training. We'll stop paying for it because we can't really afford it anyway. That's ChatGPT. It was kind of an unintentional product, right? They were sort of at an inflection point. They needed some more training, testing. And if you remember the early version of this, it largely always provided multiple responses. It was really a byproduct of that. And it was very obsequious. It was trying to encourage you to respond more, because its whole mechanism was to get more feedback and more feedback to try and train more data. But a crazy thing happened. They put it out at the end of November of 22, and by January of 23, 100 million people had signed up for it. I had an opportunity as the .NET Rocks guy to talk to a couple of folks that were working on this thing at the time, right? And believe me, those 2 months were absolute madness. Nobody planned on 100 million users. Like, there's a whole bunch of Microsoft Azure folks that like did not have a good Christmas because they were just trying to keep the system running with this many users being added to it. Just a massive, titanic scaling problem to get to that point. But when I asked Shalace about this, I said, like, why do you think 100 million users signed up? He goes, I think it's because we did it over Christmas and people would rather talk to software than their loved ones. Which is fit. Like, get a dog. Like, that's weird. Like, why are you talking to software? Anyway, that 100 million user mark is kind of a big deal. It's a metric that the tech companies talk about in terms of viability of a product and so forth. And so that's the insanity reigns. And I would argue that's our inflection point. You know, in the Gartner hype cycle train, that's your technological trigger. Right? If we go back to like the dot-com boom, what was the technological trigger? It wasn't the internet going public. That was not a big deal, or being made available to the public. It was Netscape IPOing, and all that money came pouring in. That was sort of our technological trigger that overspent wildly on the potential of the internet that ends by 2001. And that's when Gartner originally crafted this idea of you have a technological trigger that then rockets up this ridiculous set of expectations. As you're out there trying to raise money on this technology, you just keep promising investors bigger and bigger returns until you get to a point where nobody believes you anymore and you can't deliver on what you've promised. And then down you go into the trough of disillusionment and some fallout from all of that. But it is actually a valuable technology. And if you think about it reasonably, there is a place for how this technology fits in. We went through this between 97 and 2001, and we still use the web today. It's a better web than it was back then, but that's sort of the reality of it. And we've seen a bunch of these. I use the dot-com boom as a reference just because it's sort of the best known one for most folks, long enough ago, but still relevant to the equation. So here we are. And we've in 23 with this technological trigger, and we've been riding the madness ever since. And it's just a question of where are we on this arc right now. First product out of the gate from Microsoft, because they were already working on it, was codenamed Sydney, which is a natural language interface to Bing, was to apply the OpenAI interfaces to that. In fact, in January of 23, Satya Nadella did an open letter internal to Microsoft. This is something Bill Gates used to do all the time. This was like the internet tidal wave and trustworthy computing. Well, this is the first time Satya, as CEO, did one of these. Basically told every product team, here are the OpenAI APIs, get to work, make a Copilot. Apparently internally there's hundreds of them, most of which will never see the light of day, and that's probably a good thing. But Bing was first out of the gate. They were the furthest along, and it's funny because Satya used to run Bing before he was president of Server Tools and then CEO, so it's not surprising. And both guys who used it thought it was really great, you know. So it didn't catch a lot of gravity. But it did kick off another version of GPT, and so by March of 23, it's just not a lot of time. We're up to 1 trillion parameters. Microsoft kicks in another $10 billion, so they're up to 13 billion to be able to build this larger and larger model, and the wave of Copilots start coming along. Microsoft's talking about Copilots in all of the places, arguably way too many Copilots, even though we're not seeing most of them. And you know, it's interesting to see them all in. It's a bit overwhelming, like certainly the lashback now, but this is only 23, like it's barely 3 years ago. OpenAI starts to really like, okay, we have $10 billion now. What does GPT-5 look like? And they really struggle to make a new model. At the rate between 2019 for 2 to 23 for 4 is pretty fast to do 3 versions in that amount of time. Now they're trying to come up with something big enough to make a 5. And there's a bunch of interval stops on the way. So 4.0 was the multi-platform and the multi-aspect version where they can handle video and audio and images as well as text. And in the midst of that, DeepSeek comes out. And of course, there's a bunch of other competitors moving at the same time. But DeepSeek, this is in 25, that DeepSeek releases, hey, it doesn't have to be this big. You know, admittedly, they've taken advantage of a bunch of the technologies come before, but they're like, you can make a smaller model that is fairly functional. and in a restricted environment. It just sort of opens the door to the idea that they'd had a couple of versions of 24, but this one that came out in January 25 was very powerful, and it sort of just was a reminder. Not that the tech giants cared. They just, Microsoft said, okay, it's in the Foundry too. Let's steam on by, and kept on going. But it was there's a lot of incentive for the tech giants to just keep going bigger, to follow that neural scaling laws paper and run in the direction we've been running in, even though we're getting hints that there's other possibilities and other directions to go in. And the programming language side of this seems to be a shiny part. It's being more successful than a lot of other areas, and I think there's a bunch of good reasons for that. First is that programming languages are somewhat more coherent than human languages. Lisp notwithstanding, but I could pick on a bunch of languages right now, actually, if I think about it. But you think about the tooling we've got. As developers, we're kind of used to this tooling model. We're used to criticizing other people's code, even if that code is not from a people, but from a software, right? We've always had code generation. This is just a re-entrant, non-determinated code generator, where I can sit at the same prompt 3 times to get back 3 different kinds of code. But it's manageable, and we're seeing the tooling scale up. This is a shot from Build last year in 25 of, now we're actually creating issues in GitHub and assigning them to a co-pilot who then produces a PR request that you can iterate with and sort of create a context around trying to get quality code out of these tools. There's a lot of different strategies to try to approach that. In fact, we know there's a lot of strategies because there's just so many products. Like, as someone who's been in this industry for a number of decades now, whenever I see this explosion of products, like, this is an unsolved problem. If there was a good way to do this, there wouldn't be this many of these. We also saw a very ruthless side of the tech giants where they're not buying these companies. This is not 2000 and the dot-com boom, where you built a cool website and got a bunch of market share, and one of the big players came along and acquired you and carried that thing forward. Oh no. Now, if you're clever and you've built some fairly cool stuff and you're getting some results, Google will come along and just hire all your senior staff away and pay off your investor and leave the shell of the old company behind, which is a little gross, but everybody's moving fast, like they're incented to make this look more urgent than it actually is. Not saying it isn't important, but a side effect of the hype is creating an urgency. Like, it is disruptive to the way we think about software. There are certain classes of programming, we're all developers in this room, that when you think about what a natural language interface combined with technology like MCP could do, like, why would I write an ERP system today? If I'm an accounts receivable person, I'm essentially a forms over data slave, right? Where I have a set of queries that are presented on a screen that show who hasn't paid. I then prosecute to get those payments, and as they come in, the list changes. Like, that could be a set of prompts that are able to fetch data reliably. There's certain classes of software, it's faster to modify the prompt than it would be to revise those forms. I mean, forms over data has been in a flux right now anyway with low code, no code. So here we have a next order of this. Depends on the software. Nothing is universal. It still takes a skilled operator and it still takes domain knowledge, but we're definitely sitting in a disruptive period of what software looks like right now. And I could see the hesitation in folks of like, what does it even look like? In the end, our job wasn't actually to write software. It was to provide solutions to problems for customers. And there's a bunch of ways to do that, right? Lots of folks poo-poo the no-code solution, and the guys who are good at it, it's like the VB guys back in the day. They're crying all the way to the bank because they solve certain classes of problem really quickly, and this might be another generation of that. We're just not sure yet. It's happened very quickly, and there seems to be a huge urgency around it. There is productivity potential both in the way that we currently build software and the different kind of software we could build. Now, we did eventually get a GPT-5, and this is in the summer of 2025, and it took a while. That was 2.5 years since GPT-4 with a couple of stops along the way, and it wasn't that popular. It wasn't that big bang. Like, the jump between 3 and 4 was massive. Like, holy cow, trillion parameters, this is awesome. Wait till we get to 2 trillion parameters. I remember talking about, well, what's GPT-5 going to be like? And it's like, at some point you have indexed the entire internet. that means 4chan's in there. Like, that's not good. You don't want that in there. That's bad. Like, we need some data quality here. Like, I think a smaller model that's less dumb seems more compelling, right? Like, we're up against what this even looks like. There were some other elements about GPT-5. Like, OpenAI initially came out strong on, this is the most literate of the GPTs so far. It will write in a style of Charles Dickens. And some folks that really know literature well started to experiment with this and said, this thing writes garbage. But what they noticed is when they used another GPT to ask it what it thought of the language it produced, the GPT thought it was brilliant. And it sort of pointed to, and there were some great papers written about this, they did the literary training by doing adversarial training between two different models until the one model said that that model was doing a better job. Nobody actually looked at the sentences and realized they were incoherent. Little detail. Right? But they're in their own bubble of we can train our stuff on our stuff, right? If you keep making photocopies of photocopies, it will get better. And so we saw elements in GPT-5. It's also actually not necessarily a bigger model, but a more efficient model. They're trying to tighten up the costs. We've recently seen with OpenAI's own reports that they're starting to cost less. They're not charging less, but they are trying to get their costs under control. So there's a lot of optimization that went into 5 at the expense of certain other things. So where does that put us in this cycle? I don't think we're at the bottom of the trough. I think we've been on the way down for a while. Everybody's anticipating kind of the end of the game. We were just talking about how Microsoft on Wednesday put out their quarterly report, and their stock took a big hit. Even though they had excellent sales in AI, better than expected, they didn't quite make their cloud numbers. Like, they were off by a percentage point or two, and the market reacted really strongly to that. And one of the descriptions I heard of it, it's like, all of the investors are standing at the edge of the cliff saying, do we jump now? Now? Is it now? And so they're prone to overreacting. The market is sensitized because everybody's very much looking at this graph and going, I don't want to be the guy caught at the bottom, right? I want to get out earlier than that, and I'll catch it on the way back up again. But I also struggle with, like, is this necessary? Is this the only way new technologies get built? Like, this is an especially egregious one. And so part of the conversation is, like, what's the motivation here? Why create this much urgency? Why encourage spending this much money? Why encourage clearly overinvestment? And part of it is got nothing to do with the technology. You've got to look at the incentives of the players. And one of the big incentives here is data centers. Of course, the crisis has been around. AI demands a lot of data centers. And the computational inefficiency is a feature now. If I really actually need more data centers, being more efficient would mean I don't need as many data centers. These three big tech giants that are dominant in the data center space, the Amazon, Microsoft, Google, they were struggling to build data centers in the late 2010s, early 2020s. People don't like them. They take up a lot of power and water. They're noisy. And so you started seeing reports about them saying, like, we're having a tough time building data centers. And then the AI wave came along, and suddenly we need data centers to do AI. And AI is really important. It's going to change everything. And that urgency made it easier to build data centers. So they were incented to keep this urgency running so that they could do the land grab. Like, in a lot of ways, you can see they're just cementing their lead. They're also spending cash they have. These companies are cash rich. They often do stock buybacks and things just to keep the share price moving and to do something with all the excess money they have. And here was an opportunity to spend that money. And they were doing it largely, so far, been doing it through shell companies. If you know Microsoft's bringing a data center to your town, well, you're going to charge double. So they create a shell company that's going to go out and do the shopping for the land and pre-order all the equipment and so forth. And so they've also created a supply chain trope. One of the ways I've heard this described is they're trying to get Taylor Swift tickets and they got 10 browsers open. Because they only need one set of tickets, but they think it increases their chances to do more. And so they're grabbing as much land as they can find, ordering as much equipment as they can find, including equipment that doesn't even exist yet, filling up the pipeline on the chances they're going to get 2 tickets. And so we fomented a crisis effectively to keep these companies ahead. And they're also afraid there is going to be a breakthrough and they're going to be left behind. And so the spend is catastrophic. It's literally distorting the US economy. that the capital expenditures of these companies are absolutely massive and growing by leaps and bounds. And they've distorted the US economy in the sense that while the rest of the economy appears to be slowing down, the tech expenditures are filling that in, keeping stock prices high and apparent economic activity high, while the rest of the market does nowhere near as well. And it's the S&P 500 is the real manifestation of this, that in 2024, 45% of the growth of the S&P 500 was, or 55% of the growth of the S&P 500 was 7 companies, the quote-unquote Magnificent Seven. That was just the growth numbers. The overall numbers today, 40% of the value of the 500 companies in the S&P 500 is 7 companies. To the point where you can now buy an index fund, because the whole point of an S&P 500 is you can buy an index fund that buys proportionally across those 500, so you got some coverage. You can now buy an S&P 500 minus 7 if you want, because there's, they'll always make you a product if you want it. But it's not that these companies are that big and worth that much, which is both true. It's that it's only for one reason. And when that reason changes, they all go together. Now, they're not likely to go bankrupt, right? Most of them have only been spending cash. So they'll be fine. But the haircut is important. That is a big change in the economy, 20, 30% of shrinkage. And you can see their behavior is anticipating that risk. Bloomberg a little while ago put out this great diagram about how NVIDIA doing self-dealing, which is, again, I pointed to Microsoft with the billions they put into OpenAI, largely to spend at Microsoft. Well, NVIDIA's been doing the same thing, investing in small AI companies so that they could make orders for NVIDIA parts. I kick you $500 million as an investment. Now I have a $500 million investment. Ooh, look, I got a $500 million order. Handy, right? And that keeps the appearance of NVIDIA growing with assets in investment and assets in orders, even though it's the same money, right? It's scary. It's distorting. It's also symptomatic of the end of a bubble, right? The only way you can keep producing the numbers to keep the investors engaged is to keep racing up that crazy pipeline. And so we're in this run up to sort of the fall off of this. And we're kind of waiting for the bull trap, right? We're delusional and the greed is running. It's hard to get out of these markets because they're growing so quickly and you're going to miss the boat on it. But we're waiting for this sort of bump. This was the shape of the fall off of the dot-com boom and a couple of others. So we're kind of anticipating that we're going to go back down. I mean, what is that going to mean for us in the tech industry? It's going to mean a return to ROI. Like, from an engineering perspective, I'm really looking forward to some of the crazy going away because there's some good stuff here. It's just being distorted by the crazy. And I'd like to work on the good stuff. The other side of when the money dries up is you actually need to be efficient. Efficiency becomes important again, and it hasn't been for several years. And so those who can optimize and those that can show return, there's this recent story that's meme-ish about an IT guy spending several $1 million on Copilot licenses, getting sign-off from the board to buy them all, getting congratulated for installing them, with no metrics of utilization and no evidence of productivity boost. In fact, they didn't even ask because the hype's working, right? That's the problem. Really, we need a measure of what the consequences of these things are. There's another aspect of this. I mean, these are economic things, and yes, they're going to affect us. If you think about what it was like to be a web developer in 2003 and 2002, 2003, 2004, yeah, that. But let's talk about the psych issues that have been going on. People are abusing these chatbots. Like, they think that there's no difference between the WhatsApp icon and the ChatGPT icon, right? Except that the ChatGPT icon responds any time of the night or day and always has a nice thing to say. And not that long ago, it's not kids, or not just kids, it is kids, but this is Jeff Lewis from Bedrock Investments. Guy invests in AI tech. And a year ago or so, he put out this series of tweets about how he knew that he was being pursued by non-governmental entities. Like the challenge with this software, if you spend too much time with it, is it takes a personality quirk and turns it into a full-blown mental health crisis that leads to serious, serious consequences. And it's not like these tech companies don't know this. One of the things that happened with GPT-5 was that they dialed down the obsequiousness. And they also took all the other versions offline. They wanted people to move to a more efficient model, and it is less likely to create mental health crises, except that doing that created a bunch of mental health crises because people were missing their friends. And there was this crazy message on Reddit when they put 4.0 back online, so people got their friend back. Yeah, my baby is back, and I'm crying. It's software. Like I'm scared for this person and how many others that are in this situation. It is also an issue we have with new technologies, that technologies get abused. The fact that this one's particularly good at creating mental health crises is concerning. And particularly good still meaning single-digit percentage points, but that's still thousands of people. And we will get over this, like we will find a way to get better at this over time, but it's part of the problem of these tools. And while we're in the hype cycle, it's really hard to focus on this. Now, the superintelligence part to me is a whole other can of worms, and I don't think it's the most important part by far, because it's really not a thing. Altman has been hiring and recruiting all of these scientists into OpenAI on the chant of AGI, 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 AGI. I'm also really liking the statistics that show that the more you understand about how these tools work, the less you trust them. That the most enthusiastic people are the ones who don't understand them. Like that gives me hope. But it also means we are irresponsible when we don't educate, because the more you understand, the better off you're going to be. Most of the responsible scientists are saying there's no path to AGI. That doesn't mean this technology cannot destroy our society. It can, but it will be people using it. AI doesn't lay off people. People use it. People lay off people. But they often use AI as an excuse these days. They've used other excuses in the past. You know, the real realities around workforce restructuring are more complicated than that. They always have been. If you really dig into the sciences of making a larger intelligence, I like Roy Blatt's book. It's one of the most difficult ones I've ever read, because he really digs into the essence of what it is to be intelligent, what it is to be sentient or conscious. And the more you read that stuff, the more you're like, this is not what we're working on or anywhere near to. So I see that as largely a red herring. The harm that comes from these tools will be the people that use them inappropriately. And that's still an important part. We've seen a lot of harm. Some of it is old. I don't know if you remember this. We'll see if the audio works. Do you remember this? This is 2017. This is the state of the Washington State University made the original deepfake.
They could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or how about this? Simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things.
This is before they could do the voice models,
at least not in a public address. But someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you. And stay woke, bitches.
2017. Fast forward to like 2025, and some guy waiting for, or 2020, some guy waiting for Trump to get arrested is able to make a graphic of Trump getting arrested and throw it up on Twitter, right? Like now these tools are becoming trivial. If you want to learn how to use them, they're easy to do. They're everywhere. That's, you know, although at the same time, we're also seeing the skepticism of the average consumer going up and up and up. Don't trust the videos you see. Don't trust the audio you see. People are responding to this, and we're hoping for better tools. We're probably going to have to build better tools to make it easier for folks to see that stuff. Like we are talking about a kind of Laszlo's means, and the EU and I think is further ahead on what are appropriate technologies, what are inappropriate technologies. We are seeing some legislation, but we can't count on legislation. It takes too long. The tech's moving fast now. And that really is where it falls back on us. You know, we're the folks in the seat making the programs. We choose what happens with this technology. It's what we write with it. And we've seen bad technology even before AI was a thing. Think about Grayball. I don't know if you remember this. This was Uber. Uber got $60 billion of investment. Nobody makes good choices with $60 billion. It's essentially impossible. Now, Uber clinged onto a niche. They found this weak point. The taxi industry has been pretty slack in serving people well. And so here was this opportunity for anybody to be a taxi driver with an app that made it easy for you to get your destination, get a price, keep your billing under control. Like, a lot of that stuff was good. But the taxi industry doesn't like being attacked like that. And so they went to the legislators to push back on it. And so in many regions, they were resisting it. And so Uber added some software to deal with the regulators. The regulators pulled it up. They knew the EMEA code for that phone. That phone would show no cars available. See, Uber doesn't do anything. But the regular person worked like a charm. And it worked for years. They concealed from various governmental folks what Uber was actually doing, until finally one of the programmers of Grayball leaked it to the press. Like, they wouldn't have found out otherwise. It didn't really stop them very much, but it did bring forward this idea that we can write horrible software. And, you know, maybe that guy wanted to keep his job, but he also eventually leaked it, so maybe we got some response on that. A little closer to home, maybe Cambridge Analytica. You know, that's some fairly evil software there, friends. Leaning on this idea that the average consumer of Facebook didn't know that the ad they were seeing was custom tailored to them. They were the only ones seeing that ad. And so you were literally manipulating at the individual level. You don't need AI for that. You can do this horrible stuff without it. And we haven't heard from them much, and I'm kind of glad about that. But we do get to pick what we do with this software. And there's a real push on maybe all of this generative AI stuff is bad, and it's simply not true. And I'd point to another UK entity, DeepMind. So this is Demis Hassabis, who really wanted to make an AGI. That's where he started, and built out DeepMind in the UK, got ultimately acquired by Google to fund a lot of his stuff, which is unfortunate, but he also refused to go to Silicon Valley. He stayed in England. And their initial focus was on video games. Right? They built a generalized video game player that would learn to play the game on its own. It's, the first time we saw this really shine was a breakout game where you saw the tool very precisely getting the ball behind the back row there to do a lot of hammering and so forth. And it played a bunch of different games well. Now, that's not particularly important stuff. Then those folks turned their attention to Go, which is supposed to be an impossible problem. You know, we figured out chess, but Go's got too many moves, so there's no way to do this. And they built the AlphaGo model, where they trained it on top-tier players over several years and finally became the best player in the world. They didn't quit there with AlphaGo. They moved on to AlphaZero, where they did a different training model. Took two instances, both knowing the rules of Go, playing against themselves, trained in a matter of weeks instead of years, and became a better player than AlphaGo. Again, not important, but that was their learning. When DeepMind started making a difference in the world is when they tackled protein folding. So I don't know if you want to put your biology hats on. Let's go back and talk about the proteins we learned about in college. There are 80 important amino proteins, some of which your body produces, some of which it doesn't. But pretty much everything in organic life depends on these proteins in one form or another. And these proteins click together in a bunch of different ways. And when they connect together, they then twist up to expose different proteins in different forms. This is what protein folding is all about. Those peptide bonds are all unique. And when you can work out exactly how these work, you can do some remarkable things in biology. So if we go all the way back to, again, an Englishman, John Kendrew, he spent 12 years working out the myoglobin protein structure. Because they're so small you can't see them. He created X-ray crystallography to solve this problem and got a Nobel Prize for it, because once we knew how myoglobin worked together, we were able to fight things like leukemia. But there's millions and millions of different protein combinations. Over the past 60 years, tens of thousands of biologists putting in hundreds of thousands of hours have worked out about 100 protein fold models. X-ray crystallography has some restrictions. You need to have really stable proteins to make all of that work, to the point now where there are missions on the International Space Station to do X-ray crystallography, because in free fall, you can actually form those crystals better, do those measurements, because it's so valuable when you can work out how these proteins work together. And so DeepMind turned their attention to how these different proteins work. There was a competition going on called the CASP competition for understanding prediction of protein structures, going all the way back to the 90s. After 20 years, like by 2014, they'd made almost no progress at all. One group had actually made a video game to allow regular people to be part of the protein folding problem. It's called Fold It. And believe it or not, they actually worked out one protein. It was a protein involved with the effective elements of aflatoxin, which is a plant disease. And so that led to a treatment to stop aflatoxin on plants. Like, cool, just not efficient, right? And so they took the AlphaFold algorithms and applied it to understanding protein folding and went through several iterations, mostly through the beginning of the pandemic, and entered CASP competition and scored the highest in history. That took almost 2 years to even validate, but they only run the competition every other year. But by 2022, they were at 90% accuracy. So they basically cracked how protein folding worked. Now, and a bunch of different entities are all trying to figure out protein folds for different treatments, basically went to them and said, can you work out my protein? And Demis's answer was, why don't we just do them all? And so they worked out the protein folding patterns for 200 million proteins and gave them away. Our medicine's fundamentally changed and we don't even know. So far, we found a vaccine for malaria based on those protein foldings. We found a couple of new treatments for different blood-related diseases. Like, we're just working our way through that. We've largely cracked antibiotic resistance. We discovered 2 new antibiotics off the back of this. Gave it away. We choose what we do with this technology. We have examples. We just have to decide to do it. It's up to us. I hope it was useful for you. Thank you for your time.